guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. So today we have a pretty interesting video that I'm very excited about. So let's go ahead and read the problem statement. So the problem's called sort colors, right? It says giving an array of nums with n objects colored red, white, or blue, sort them in place, right? Okay, so that the objects of the same color are adjacent with the colors in order red, white, blue, right? So we will use the integer 0, 1, 0, 1, 2 to represent the color red, white, and blue respectively, right? So it says you must solve this problem without using the library sort methods, right? So cool. Good thing that it told us that we can't use sort, what I'm saying. We can't use the library sort because either way it wouldn't be too good anyway because the time complexity would be n log n anyway. So yeah, so that's a good thing. It told us that they want it in place, guys, in place, so no additional data structures, right? So yeah guys, so right now this example that's given to us, right, pretty much it said the zeros represent red, 1 white, blues or 2s or blues, right? So we need to partition in a way that all the zeros on one side, all the ones are on the side, right, and the 2s are their own section, right? All of them are in their particular respective sections, I'm saying. So no matter what the order is in, right, just make sure that you organize it in a way that all the zeros all together, I'm saying. So that's how they want them. So this example is a pretty good one. So I know it's pretty much randomized, and you see that after we apply the whatever algorithm that we're going to use, right, all the zeros are together, all the ones are together adjacent to each other, and all the 2s are together as well, guys. So pretty much, yeah, so he said they're adjacent pretty much. So since we can't use sort, right, which would cost us n log n, there's this pretty good algorithm that we can use, or technique. It's a pretty good technique, right? We've used this technique a lot. We have numerous problems on this channel that uses that technique. So the technique that we're going to be using, guys, is going to be the two-pointer technique, guys. So it's a very, very good technique to really master, I'm saying. So if you guys are not comfortable or new to the two-pointer technique, I got a playlist that should pop up here, so you guys should go check that out, so that you guys can have the intuition to pretty much solve this question and be able to understand my thought process, how I'm going to explain to you guys, right? So yeah, so the way that the two-pointer technique is going to be useful to us, right, we're going to have the left and the right pointer, right? So one that starts at the beginning, one that starts at the end, right? And then their job, right, pretty much gonna help us in placing those numbers in the right partition, right, where they belong, right section. So the zeros, right, are gonna be at the beginning, right, which the left is gonna help us to populate that, and then the right pointer is gonna be at the end, right? Then the right is gonna help us put the 2s to the back, right? So all the zeros, right, are gonna be coming before the left pointer, right? And then all the 2s are gonna come after the right pointer, right? So that at the end of the algorithm, guys, we're gonna have all the 1s between the left pointer and the right pointer, right, inclusively, right? So that's how the whole thing's gonna work. So I'm gonna go through an example, you guys, to really show you guys how the algorithm's gonna work. So yeah, let me quickly show you guys an example. All right, just drop this in right there. All right, so this is this example that's given to us, 2, 0, 2, 1, 1, 0. Right, so we're gonna be applying the algorithm that I just talked about. So hopefully you guys are able to get it. Okay, so right now pretty much we got the left pointer and the right pointer I talked about, right? So initially they start off by being at the beginning and then one at the end, right? So now this I pointer, right, is gonna pretty much help us, guys, in iterating through the array, right? So we're gonna iterate through the array, and as we're iterating through, right, we're gonna be placing the zeros in the right partition and the 2s in the right partition, right? So that everything is set in our right. So let's pretty much, like I said, so iterate. So if I, right, points to a 2, right, then what we're gonna do, guys, we're gonna swap it with the help of the right pointer, right? So we swap after we swap the 2 numbers, right, we're gonna decrement the right pointer, right? So that the 2s, like I said, are gonna be to come after the right pointer, right? So right's pretty much serve as the boundaries, and the left as well is gonna help us populate the zeros, kind of serve on the boundaries, right? And the left and the right, like I said, when we're done, I'm gonna be pointing to ones, I'm saying. And yeah, so let's go, let's continue. So right now, guys, we have so I points to 2, right? So now we have to swap it with the whatever the right pointer is pointing at, right? So we do a swap. So this becomes 0 and this becomes a 2, right? So we have to, now that we did this operation, right, we're going to decrement the, since it's not, we just processed that spot, right? We're done with that spot, so we're good. So we decrement the right pointer, right? And then the it goes back, and then we ask ourselves this number that we just moved, right? Remember, you see that we didn't go forward, right? That's the other iteration, right? So that we didn't go forward, we do a check, right? Before we move forward, because we don't want to move forward, and then we just, let's say there was a 2 there, right? This might have been a 2. This might have, what I'm saying. So that's why we don't move forward. We wait for the next iteration. We ask ourselves, is this a 1, 0, 2? Right? We want to know what it is, right? So it's a 0. So, and since it's a 0, we swap it with whatever number the left pointer is pointing at, right? So it's a 0, so we swap it with the left pointer, right? So the left pointer 0 and the I pointing at the same number, so there's nothing that changed, right? So they both move forward, right? We just processed that number, I'm saying. We just process, so we leave that, I'm saying. So they both move forward, and then we do the same thing, right? This is a 0. We keep doing that. We swap it. I get swapped with the left pointer, right? They get swapped, and then they both move forward. So now the left pointer pointing their eyes pointing to the same place, right? We see the right pointer. We didn't use the right pointer, so the right pointer stays put. It keeps pointing at the 1, right? At that particular spot that it's pointing at, right? It doesn't move because we're not taking care of it yet. So the I now, right, is also gonna move forward, guys. So we no. So the I. So we pointing at a 2 now, right? We ask ourselves, does this 2? It's the 2, right? So now the right pointer is gonna help us in placing that 2, right? So now we gonna be swapping with the right. So pretty much, yeah, we swap with the right, guys. We swap with the right. So this becomes a 1, and this becomes a 2, right? And then we decrement the right pointer, right? So, and then now we go on to the next iteration. We don't move I, right? Whenever we place the 2 and we swap it with a number that the right was pointing at, we don't increment I. We wait for the next iteration and we check to see what kind of number it is, right? Yeah, so right now we check, right? It's I is a 1. So I, since it is a 1, right, we just increment, boom. And then we check I, it's a 1, right? We just increment. Then we exit out of the loop because I crossed over R. So I mean the array is sorted, guys, just like that. The array gets sorted. So pretty much, guys, to recap, once we iterate through the array, right, with the index pointer, and then we got a left and the right pointer pointing at the beginning and at the end respectively, right? And then once we encounter 0, we place the 0, we swap whatever number that we that the left pointer is pointing at, right? And then now the left pointer helps us to update whatever the numbers that towards the beginning, right? And then we increment the left pointer, and then once we encounter a 2, we do the same thing. We update the variable that whatever number that the index that the right pointer is pointing at, we update that, and then we decrement it so that after we're done placing everything, we're partitioning everything, right? The left and the right are going to be pointing at the ones, right? All the ones are going to exist between the left and the right pointer. So this is, you see, indeed, that my statement was indeed true, because they're pointing at all the ones pretty much that exist in the array. So hopefully you guys were able to follow the thought process and understand kind of what I'm trying to say. So let's quickly implement the algorithm, guys. So first things first, right? We're gonna have this index variable that's gonna help us to iterate through the array, right? And then we're gonna set at the left pointer, and we're also gonna have the right pointer, guys. -1, right? And then, guys, we're gonna pretty much have a while loop, right? So while the index, guys, is less than or equal to the right pointer, less than or equal to the right, those are all the boundaries, right? So we're pretty much gonna take reference to whatever number the index pointer is pointing at, right? And then we're gonna check, guys. We're gonna ask ourselves a series of questions, right? So we're gonna say, is that number a 0? If it is a 0, right, we're gonna swap it, guys. We're gonna call swap. We're just gonna swap it. So I'm gonna implement that function in a little bit, so don't worry. So we're gonna pass in the array, and then we're gonna be swapping it with the left pointer, right? With the whatever index pointer that we're pointing at, right? And after we're done swapping them, right, we're gonna increment the left pointer, and we also increment the index pointer, right? So they can both move forward. And then this other case that I talked about, if the number, right, equals to 1, right? If it's just a 1, right, we just move forward. We do nothing, right? We just go forward, right? There's no swapping to be done, right? But if it is a if we encounter a 2, guys, I told you guys we're gonna put all the 2s. All the 2s are gonna come after the right pointer, right? And all the 0s are gonna come before the left pointer, so that all the 1s exist between the left and the right boundary. That's the whole point. That's why we do this. We just increment. Oh, it's a 1, then we don't mind it. We just move forward, right? That's the whole point. So now we encounter a 2, right? Since we took the case where 0s and 1s, right? So the next case that's left is a 2. So pretty much we pass in the array, and then we also pass in the index, right? And then we pass in the right pointer. And but after we're done swapping, we decrement the right pointer, right? So let's quickly implement the swapping, right? The swapping is void swap, right? So we take in the array, and then we take the index I, index j, and then we do a simple swap, right? So we take reference of this nums of I, right? And then we're about to overwrite nums of I. That's the whole point of taking reference to it, right? We take whatever number was there, because we're gonna overwrite it, right? And then we overwrite it with nums of j, and then we update nums of j with the original nums of I, right? Which was saved in the temporary variable, right? Seems like we got everything correct. Let's just go quick recap. So we got those two. We got the index, right? That's gonna pretty much help us iterate through the array. And we got the left pointer, which starts at the beginning, right pointer starts at the end, right? And then we got index until we hit the right boundary, right? And we take reference of a number, we check if it's a 0. If it's a 0, we simply swap those numbers, right? The left pointer and the index, right? And then we increment both of them, right? To move to the next spot, right? Since we just processed the left pointer, right? We just go on to the next number. Whatever, yeah. And if it's a 1, we just go forward, right? The index pointer, we just go. And then we encounter a 2, right? We swap it with whatever number that the right was pointing at, and we decrement the right. And then the index, we don't move it forward, right? We wait until the next iteration to see the number that we just swapped with the right pointer, right? Is that number, we want to know which one it is so we could act accordingly, right? So let's press run code, see if we pass these small test cases. Nice, guys. Let's see, press submit. Perfect, guys. We're able to pass all these test cases, guys. So I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this, and I'll see you guys in the next one.